Good evening, Ashish.
Good evening, good evening.
Ashish, am I audible to you?
Yes, yes, you are audible.
Okay, that's good. So, Ashish, have you solved those problems related to Gumbel's method? Because today we are again going to see those problems. Okay.
Okay, but I haven't did, but yesterday what we did, only that one I have done.
Then I just want you to go through those questions once last time, so that you should have the idea of steps. Okay, that how we are going to approach.
Okay, okay.
Yeah. I will wait till 6:10, then I will start the session.
Sure.
Good evening, Bala Murugan. Okay. So Ashish, when will be your exam? Like this NPTEL?
19th.
Okay, on 19th. So today is 9. Okay, got it. So after 10 days you are having an exam.
But I think we haven't received any information from NPTEL.
Then you will receive that. It will be online, na? In the form
Offline,
of MCQ.
offline, offline, offline.
It will be offline.
Yes,
Okay. That's good.
I already given one paper earlier last year.
Okay, okay. Good. So offline they will be giving you a center.
Yes,
Okay, they will be allotting a center and then you have to go there and write that paper.
just like engineering semester exam.
Yes, 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 got it. Right. Okay, so welcome once again to the last assignment session on the course Engineering Hydrology. I'm just now presenting my screen. Let me know whether this is visible to you. Ashish, can you confirm whether this screen is visible to you?
Yeah, it's visible.
Okay, I hope I am audible as well. Okay, now, so today in this session, we will cover the following topics. So the topic related to design of hydraulic structures, then the numerical examples of probability distribution, then there will be some numericals based on risk analysis, also the reliability concept, we will also look into that, then design storm and design flood. So before going to this, I will be taking few questions from this topic, because those few questions, like 2 or 3 questions, was not covered in that session. So I will be starting this session with those problems first related to design flood, and these are based on the Gumbel's extreme distribution. So this is the first question based on Gumbel's probability distribution. So here you can see the following observation from this question. So the question is given that in a river, annual maximum discharge follows the Gumbel's distribution. So whatever the discharge value was obtained directly from the observation in the field, it was distributed following the Gumbel's method, and after establishing the distribution, it was found that mean value of the entire data was
Yeah.
10,000 cubic. So here the values are given as x bar, that is 10,000 cubic meter cube per second. Then, okay, wait a minute, someone is trying to join. Yeah.
Good evening. Good evening.
Yeah, good evening, ma'am. Yeah. Okay, so just I was giving some brief explanation to this question, so that what are the information that is provided in this question related to Gumbel's distribution method. So here you can see that for Gumbel distribution method, it was applied to the discharge data taken from a river, and after establishing the distribution, it was found that the mean value of entire discharge data was about 10,000 cubic. Then also standard deviation, like that is representing a spread of data, that how much it is spreading from the mean. Okay, so for that sigma was given, and that is equivalent to 3000 meter cube per second. Now the further, there are some more information is given to this, is that we need to find out the probability that annual maximum daily discharge will exceed 15,000 meter cube per second. So that means this is a target value, right? So here, because for this case, this is the target discharge for which we have to compute the probability. Okay, so in that case, this is given that xt is of about 15,000 meter cube per second, and then there is one more information that we need to find out the magnitude of annual maximum discharge with a return period of 100 years. So that is another task, because here the return period is given to us. Okay, so firstly we need to compute the probability, that is P. Okay, and that could be possible only, what would be the relation, how we can achieve this, how we can achieve to this point. If we want to compute the probability of daily discharge distribution, so how we can achieve that, how we can compute this P? Is there
One by return reciprocal of return period.
Yes, right ma'am, you are right. So it will be a 1 upon T. So but from the question point of view, do we have the value of T here directly? Leave this part, because this is a separate question. Okay, this is for the another condition. So for time being, do we have the value of T? So of course we don't have, right? But we have an idea related to xt. So xt is given to us, so this T we have to determine using the Gumbel's distribution. Okay, we have to determine it. And how we can do it? What is the relation, like what is the basic empirical relation given by Gumbel's distribution? There is an equation which is fitting the Gumbel's distribution, that is xt equals x bar plus k into sigma.
Yeah.
Am I right?
Yes.
Now tell me Ashish, what are the values we have right now? If we want to compute T, then what are the values do we have?
We have x bar, sigma.
Okay, and xt also we have. So can we compute k value from here?
Yeah, we can compute.
Okay, now you can compute the k value. So then if once you have an idea of k, then can you go through the process where you can determine the value of T if you are knowing the value of k? Is there any relation which is establishing the frequency factor k with return period T? Is there any relation?
K is equal to.
So k is what? K is always equal to yt minus yn bar upon Sn, right?
Yeah.
And if it is if you are talking about a large sample or large series of discharge data, then in that case we can take a constant value, that is a constant coefficient value, we can put directly here, and we can determine a yt. So from this relation you can have idea related to yt. Am I right? From this you can get yt. Is it clear?
Yes.
Yesterday we see that
Yes.
in the Gumbel's distribution it is mentioned that if we are having a large sample of data, then in that case Sn and Yn can be taken as a constant coefficient. So these values are provided in that distribution. So after using this k value and provided other parameters, we can directly compute the value of yt. And once I get the yt value, I can use a relation given by minus ln
T upon T minus 1.
T upon T minus 1. From here I can get an idea that how much T is coming. So this t, using this t value, here I can get the probability, that what is the probability for this case. Okay. Now we have to just reverse the entire process, and we will try to get the extreme maximum daily discharge for a return period. Now we have a return period. So t is here again with us, then we will compute the yt, and then we will go with the following reverse process. Got it?
Mhm.
So you can see here as well that what process is being mentioned here also. So you can see that in order to get the value, okay, I guess this will be more confusing to you as well. See here it is following, this is the second part. Okay, so this is the approach it is following for t equal to 100 years, but in that case there may be a confusion, because this is it is following, like it is assuming some of the other coefficients alpha and beta. I don't want you to go through this. Just what are the parameters given to you, based on that you can compute it. Okay, is the process clear to you?
Yes, yes.
Okay.
Yes.
So just this is the part of previous session. You can also go through the recorded lectures that is been with you, so you can have good idea that what is the process for that. Now I am moving ahead now. So here again the question is a bit more simple and similar to the previous question. Here again Gumbel's distribution method is being used, and the question is asking about the magnitude of flood with a return period of 150 years. Okay, so there is again a one similar question that we have solved during the last period of our yesterday's session. In that case you may be you can remember that we have solved a problem related to some kind of case scenario, case 1 and case 2. Okay, so here again the things are more similar in that fashion. You can consider this as a case 1, and then you can consider it as a case 2. Now apply the Gumbel's distribution for this case and apply the Gumbel distribution for this case, and then you will get two equations with two unknown parameters. And what those unknown parameter will be? Those unknown parameter will be x bar and sigma, right? These were the unknown parameters. And now after solving those two equations, once you get this x bar and sigma, you can use that data for this part, this 150 years, and then you can easily compute the magnitude of flood. So here just for your information, I am just writing the equation quickly. So for case 1, if I am using a Gumbel's distribution method, so what is the expression for that? Just we see that xt equals x bar plus k into sigma. Am I right? Now x bar, do we have information related to x bar? No. Then do we have information related to sigma? No. Then what left is k, and we know that how we can compute the value of k. How we can do it? So we just need to use this in this relation, yt minus yn bar upon Sn. Now these yn and Sn value, they are constant. You can take it directly from the Gumbel's method. So these coefficients are known to you, and you also need the value of yt. And how you can compute this yt? So see, this relation you have to use, minus ln of ln t upon t minus 1. So here t is given to you directly. What is the t value for this case? 50. So for this case you need to put t equals to 50, and you need to compute this yt value and then put this value in this k relation, and you will get a some value for k. So this will be your first equation. Got it? Also, you have one more additional information, that is peak flow. So peak flow will be what? That will be xt. So for the first case, xt will be 42,000. Then if I am applying the case second, then again I will, what will be the xt here? For the second case, what will be the xt?
48,500.
Yes, ma'am, right. So 48,500, it will be an xt value, and that will be equivalent to x bar. Since we don't have information related to x bar and sigma, we will keep it as it is. And now see that k will again, we need to determine it. K we need to determine it again for what? It will be now for t equal to 100 years. Yes. So it will be for 100 years. So once I got the k value, I will be using here. So I'm just writing it as k1, and here it is k2 into sigma. Now you have two equations, right?
Two simultaneous equations and two unknowns.
Exactly. So now after solving these equations, you will be able to get x bar, and then another parameter is sigma.
Sigma.
Now come to the target approach, that what we need to estimate here. So it is asking that we need to compute a magnitude of flood with a return period of 150. Now we got the information about these parameters. Now we can directly use again that same relation, that is xt equals x bar plus k into sigma. Now how we will get this k value for this case? Using a similar approach, this only, that k should be computed using yt, and how yt is getting, we are using the t value, that is a return period. How much it is given for this case? It is given 150 years. Any doubt till so far?
No doubt.
Okay, so now you got the value of k here, you also got the value of x bar from the two above equations, and sigma is also known to you. Now using this simple relation and computing the value, you can directly have an idea of xt. Any doubt? I hope it is more simple and it is clear to you. Ashish, should I move ahead?
Yes, yes, yes.
Okay. So just for your information, I guess by using alpha and beta, it is more complex, so I am just avoiding this. Okay, now we are moving to the today's session. So here question starts from the design perspective. So question is related to a design, that is the design flood commonly adopted in India for barrages and minor dams is. So barrages are a small kind of artificial structure built across a width of the river in order to store like a small amount of water it can. So this whatever that water is getting stored, that could be used for some irrigation purpose, and sometimes that water is used for diverting the flows to maybe in the catchment where volume of water is getting depleted now. Or sometimes these barrages are also useful in order to recharge the like groundwater, because people are excessively exploiting the groundwater resources, and in that case, if we are stopping the surface amount of water, then water is at that location for more time, so there will be maximum time for the percolation of that water to a deeper layer soil layers, right? So here question is related that in India, what is the design flood period taken for constructing a barrages and a minor dam? So if you are constructing this, what would be the period of that project? Any idea?
Is it probable maximum flood?
Okay, so a probable maximum flood, uh, it is in some cases basically we have to compute this. Okay, This is just a process based on the data. We need to compute that. But yes, for Indian perspective, for the project which are being operated, okay, for
Oh,
multi-purpose, there is a
100
requirement,
years.
minimum requirement of 100 years. 100 years flood it should withstand. Okay, so that is the
Oh, great
option
answer.
A
Thank
also
you.
here. So here you can see that a standard project flood or a 100-year flood, whichever is higher, then you can see the explanation. For permanent barrages and minor dam with a capacity less than 60 million meter cube, design flood recommended is uh, I don't remember this full form of this word right now, but it is having a return period of 100 years. Okay, so it is recommended. Okay. Okay, moving to the next question. So culvert is designed for a peak flow, and peak flow is given as QP using a rational formula. So I hope you may be having an idea, some idea related to rational formula, and what is the relation for that formula. Can you tell me? Rational formula. So it is Q equal to CIA. C is a coefficient, I is the intensity of rainfall, and A is the area of catchment. And based on these parameters, we are computing the maximum amount of discharge which can be generated to the catchment. Keep in mind that whatever the I value is coming, that duration is taken as a that is time of concentration. That T is always should be greater than or equal to time of concentration. This is a condition for this. Okay, so T should be greater than or equal to Tc. This is a condition for using the rational formula. So this is a rational formula. Now if a storm of same intensity as used in the design and twice the duration occur, then resultant peak discharge will be. So it is saying that if we modify some of the parameters, can we have some other peak discharge value? So see, QP is equivalent to CIA. I is an intensity. An intensity is always calculated in mm per hour, right? And this is an area of catchment, and this is a C value. C is a coefficient, catchment coefficients. So here the question is saying that if a storm of same intensity, so intensity is, it is saying that it is same as used in the design and twice the duration. So is there any parameter related to duration? Can you find here? So there is
Intensity, I think.
no intensity is it will be considered in its duration only. Oh, sorry, in its own unit, that is mm per hour. But additionally, there is no parameter for duration in order to uh, see the variation in observed discharge. So there is no additional parameter of duration. So in that manner, it is not going to change. Okay, because I is unit will be, it is in mm per hour, and it is saying that intensity is same, so I will be just, it will be same as it is not going to change. So whatever the hour value or this mm, they are going to be constant only, they will remain constant because intensity is same, so we cannot modify this. Now additionally it is saying that duration, so duration, it is given that twice the duration, original duration, but we don't have any parameter which is going to modify this value. So for that case, this peak resultant discharge, it will remain same. Okay, so you can see here, this is a relation for rational formula QP equals CIA. It is used for computing the peak discharge for small catchments, and this is a relation for this case. I here is intensity of rainfall, that is in mm per hour, corresponding to a duration equal to or greater than time of concentration. It is mentioned here. This is for that case. And A is the area, catchment area, and QP is a peak flow. Since there is no parameter related to duration, so in that case it will remain same. Okay, so now the question related to a risk analysis. So the risk associated with hydrologic design of a bridge. So here hydraulic structure is bridge having an expected life of 50 years. So if it is saying that expected life of 50 years, then if you remember, yesterday we have taken few problems which were representing the risk related to the construction of any kind of project. So here n is equivalent to 50 years.
50 years.
And then it is designed for a flood magnitude of return period, it is given. Return period is also given, that is t equals 100 years. Now it is asking that we need to compute the risk. Can you tell me what is the relation for risk? And see, risk will always occur at any project whenever the value, like a magnitude of any kind of flood, if it is going to exceed the specified flood value. That specified value is what? That specified value is basically representing the return period. So if that project is designed for a return period of 100 years, then definitely there will be some flood magnitude which was considered at that time, right? See, if you see that Gumbas distribution, so xt is equal to x bar plus k into sigma. So here, how we are getting this t value? From this k parameter, we are getting some idea about t. How we are getting this? We are getting it after getting an idea of somewhat maximum flood value that we are assuming. So here xt is somewhat assumed. In some of the problem you have seen that it is 26,000 cubic. Some of the problem you have seen that 45,000 meter cube per second. So what is happening? So we are just assuming, seeing the time series, that yes, in the past 10 years flood discharge have not crossed 45,000. So this will be the maximum value it can go. So using this maximum value, we are most of the time in the project, this t value is computed. So this t is always related to 45,000. Now see, this is this project, whatever the project you are looking for, it was constructed for the flood magnitude of 45,000. But now what happens? The things got changed. Due to a climatic uncertainty or climatic change pattern, we are receiving a tremendous amount of rainfall in a catchment, or in that catchment where the condition was that this value is going to increase with this threshold which was considered earlier. Like now the flood discharge I am getting is that 60,000 after that rainfall event. So this is the discharge I am getting. Do you think that structure, whatever the project which was designed for 45,000 cubic, is now going to hold this much of discharge? No, because that whatever the strength of that structure is made, that is based on the return period. Okay, and that is why risk analysis is important, because if this value is now more than the threshold magnitude value that is given here, if it is exceeding, then there is a risk. And how much risk? Now it could be possible that it is going to be even 100% also. Risk is going to be 100%. In that case, structure is not going to hold any amount of water. Now you have to directly release the water. You have to open all the gates. Okay, so risk is important. So what is the relation? Can you tell me? So here the risk relation is that 1 minus reliability. Reliability. And what is the reliability? Reliability is that probability of the structure to not fail. That is a reliability. And how we can get it? So for that case you need to have 1 minus q to the power n. What is q? Q is the probability of failure. Like that structure can fail. That is representing the q. And if I am taking a 1 minus q, then that is representing that this structure is not going to fail. And for how many years? So it is for n years. And again I am taking that this is the reliability, but I am looking for a risk, then it will be again subtracted by 1, because reliability plus risk, it will always be equivalent to 1. So now this is a relation for you. 1 minus q, or you can say that is a probability.
P.
Yes. Okay, sorry, this will be p, right. Yeah. So to the power n. So this will be a risk. Now p can also, again it can be open as 1 by t. So 1 minus 1 upon t to the whole power n. Now you have all those values. You already have n value, and n is given as 50 years, and then again t is given, and t is given as 100 years. Now if you put this value, then 1 minus 1 upon 100 to the whole power 50. Ashish, find out the value, like what is the difference? 1 minus 1 upon 100, how much it is coming?
1 minus 0.99, subdivision A,
Yeah.
option A.
Yes, this is correct answer. Right. Okay, so just for the understanding, it is mentioned here. Okay, so I guess this answer is clear. Then I'm moving ahead. Okay, so again the question is that what you mean by, what do you understand by a 60-year flood? If someone is saying that 60-year flood is there, then what
Which
is the,
occurs at least once in 60 years.
yeah, right. So this is correct answer. So it should occur at least once in a 60 years. Okay, so risk analysis. So here you can see that risk is the probability of occurrence of an event having magnitude greater than or equal to design magnitude will occur at least once during the useful time of the project. Okay, moving to the next question. So here we need to estimate the peak discharge from an impervious catchment having an area of 2 km square that has experienced a rainfall intensity of 270 for a duration equal to the time of concentration. So see, the question is asking that we need to compute the QP value, and unit should be meter cube per second. Impervious catchment it is saying, but it is also providing an area of catchment, that is 2 km square. Then rainfall intensity is also given to us, that is 270 mm per hour. Now also time is given, that how we can compute the time of duration. Okay, so for that case time is given that it should be equal to time of concentration. So see, why this condition is given is that to let you know that this condition should be applied for rational method. Like this rational method can only be used when time, that is the duration of rainfall, is greater than or equal to time of concentration. So whenever this condition is given, then rational method can directly be used. And what in the previous slide I just mentioned, that what is the relation for rational formula? QP equals,
CIA.
yes, CIA, right. So in this case, we need to take some C value also. There should be some assumption, like I hope this C value will be given to you directly. Okay, in the question itself. Wait a minute. Yeah. So here you can see that for impervious, it is mentioned directly that it is an impervious. So C is taken as 1. That is a maximum value. So now try to compute this value, that what the maximum value you are getting for QP. So 1 is here, I is also given, that is 270 mm per hour, and it should be multiplied by 2 kilometer square. So if I convert this kilometer square, I should be multiplying with 10 to the power 6 meter square, and then what left, that is mm. So for this mm, I will be dividing by 1000, so I will get a unit of meter, and then remaining is what, 60 into 60. That will give you an idea of seconds. Now try this, solve this value, and let me know what is the answer you are getting. Calculate it and let me know what is the answer you are getting.
$150 we
Yeah,
get.
right, ma'am. You are getting that answer, correct answer. Ashish,
Yeah,
are
I'm
you also
calculating.
solving this?
Calculating.
Yeah.
Yeah,
A is
150.
assumed as 1, right? QP is 150. Okay, you already got this. Good. Great.
I got 150.
Yeah, good. Okay, now I'm moving ahead. So this question is again related to a time of concentration. So what are the information is being given for this catchment? So a catchment having its remotest point at a distance of 3.5 kilometers. Okay, from the catchment outlet. So if I am having a catchment and there is an outlet, this, so remotest point at a distance of this from the catchment, so definitely it will be this distance, that is will be length, and it is taken as 3.5 kilometer. And then outlet is at elevation of that elevation is given, that is a level. So level in the sense, if I am saying that it as a h1 and here you are getting it as h2, so basically this entire that is a difference in the level it is given, that means h1 minus h2 is given, that is 70, because it is saying that a 70 meter below that remotest point. So remotest point, if I am assuming here it as A, and this is a B, that is an outlet. So for A and B, the level is 70 meters, so that will be h1 minus h2. Now how it will be useful? So it will be useful in computing the slope. Okay, because you also already have a elevation for this catchment, like you already got h1 minus h2, and also you have the value of L, that you already got it at the outlet. Now if you take the ratio of both of them, like H1 minus H2 upon L, that will be giving you a slope value, that is delta S. So, and now what left, that is the time of concentration. So, and do anyone know that what is the formula for TC? That is time of concentration. So basically this time of concentration is basically dependent on two parameters, that is, one is the slope and another parameter is L. Okay, so these, based on these parameters, you can see that there is a relation given like this. So this entire formula is called Kirpich formula, okay, where time of concentration is being computed, which represents that time required for the water flow from the most remotest point in a watershed to the watershed outlet. Okay, so this is the time of concentration. So try to see this formula and get the answers. Okay, so S you can directly get here. This will be how much? It will be like it was given 70, right? So 70 upon 70 is in meters. So if you divide it by L, so L was 3.5 kilometers, so it will be taken as 3500. Okay, then that will be in meters. So 70 divided by 3500. So this is the S value, you got it, and L you already have, that is 3500. And what left? So nothing. So TC you can directly apply, that is 0.01947. L to the power of, like, L is what? How much? 3500, right? So 3500 to the power of 0.77, and S is how much? That is 70 upon 3500 to the whole power of minus 0.385. This is a power. So sometimes you may get confused with this power, so try to solve one or two problems related to this, then you will remember these power values. Now compute this value and tell me how much you are getting. And see, whatever the C value you will be getting, it will be directly in the units of minutes. Okay, so it will be having a unit of minute. If you are having a Cal-C, then definitely you can work it out easily, else there should be some difficulty in this.
Yeah, I got it. 47.03.
47.032.
Good, ma'am. Ashish, you can also tell me the response.
Yeah, I got 47.03.
No. What is the reply?
Yeah, he already got the answer.
Ah, that's good. Okay. Yeah. Okay, then moving to the next question. So this problem is more related to a field aspect again. So what are the information that we have? So this entire paragraph, whatever the information is being given, that is already you have solved it in the previous problem. Okay, so L is given to you, that is 3.5 kilometers, and then you also have delta H, that is 70 meters. Then now what next information they are giving, that is an intensity duration frequency relation is given. Intensity duration frequency relation. So here intensity is being related with duration. Okay, so here intensity is given, then this is a duration. This is what? This is capital T, and capital T is basically a return period. Okay, so here don't confuse with this. This is a return period, and this T is a duration. A duration for what? Duration for the rainfall at the remotest point to reach the outlet. This is a time. Okay, because whatever the water is going to fall, it will take some time to travel, right, from its remotest point to the outlet. So for that time this T is taken, and this T is always in the units of minute. It is always taken in the units of minutes. So this capital T, this is a return period, it will always having a unit of years, and then this is the relation. Now you all extra information is given that I is having a unit of 70 centimeter per hour, and then T is in years and T is in minutes. Okay, the intensity of rainfall for calculating the peak rate of runoff at the catchment outlet for a 100-year frequency is, okay. So 100-year frequency it is saying, okay. So 100-year, that means frequency it is saying, that means T is 100 years.
Yeah.
Okay, so you got that T parameter is known to you. Then what left in order to get its complete value? What information, extra information do you need? You need T value. This is
T
small
value,
t.
small t.
Okay, and how you can get this T value? Just I mentioned that this T is nothing but
Time of concentration.
Yes, right. This is T is a time of concentration. So you need to put here the time of concentration. So whatever the TC value you are getting, that was 47.03
03.
minutes. So you need to put this value in this relation directly. And T is known to you, capital T is also known to you, so you can do it. Try to get this value.
So T is we got in minutes, I think.
Yeah, definitely. So here again you need to put this T is in minutes only. Directly you need to put the value in minutes. This
Okay.
empirical relation works on this
Okay, got it. Right.
parameters only.
$17.66.
How much?
17.66 I am
Okay,
getting.
so you are getting I of about 17.66 centimeter per hour. Tell me the response from Balamurgan also. How much he got?
He got 22.23.
Okay, so he got
Let me check.
22.23 centimeter per hour. We will check it. Ma'am, are you also solving? Like, are you getting the
Yeah, I'm
answer?
solving, but I haven't completed just a minute.
Yeah. Okay. So, in that like project, in the one slide that was there, na SPF, that is representing a standard project flood. So basically,
Yes.
it is representing a standard value in that case.
It was given in question also that time.
Ah, yes, right.
Yeah, 17.66 is correct.
I too got it, sir. 17.66.
Okay, you also got 17.6. Okay, let's check that what is the correct answer for this. Okay, this is a TC value. Okay, so TC here you got it. Now see, this is the value here. This is the I value, that is 22.23. How it is computed? See that. Check it properly. Or do I need to compute it again? Let me check it. I'm also computing.
The power here is 0.125, but there it was given as point not 175. Oh,
This this is
I
the
made a mistake, right?
yeah
Fine.
right. 0.125, then again 0.5. Ashish, you can also check. Meanwhile, I am
I'm
also
checking it again.
computing it parallelly so that we can have.
So 75T.125 power, I'm getting 133.370. Could you please calculate it so that
How much for what? 75?
75T to the power 0.125, I'm getting 133.370.
Yes, you are right. 133.37 is right.
Then if we put 47.03 plus 10 is equal to 57 to the power zero point 0.5, we are getting 7.55.
Yes.
But if we divide it this, we get 17.66.
Okay, okay, okay. Wait a minute.
10.52, I think.
What?
10.52.
10.52 you are getting.
Yeah.
10.52. Okay. We will check it. I'm also calculating it.
No, I think I made a mistake.
Okay, okay.
That's okay. That's 7.03. I'm getting 17.66
Yeah,
centimeters.
I'm also getting the same. I'm just asking from Balamurugan.
He is also in same line. He says 17.66 is correct answer.
Yes, right. Because this is a correct value. I am also getting the same. So here the correction should be, because the values are correct. So 17.66 is correct answer. Okay. Wait a minute. So here 17.66 will be correct answer. Okay. Confusion is T to the
He is
power.
asked the doubt, same doubt, power, whether it is point not 175 or point not 125.
It's a 0.125 is given in this question. Yeah, if I will, I'm just erasing it. Wait a minute. Yeah, now you can see here. So here the power of T is 0.125. Okay. Okay. So clear now? Should I move ahead now?
Yes.
Okay. Now there is some more.
Yeah. I found the mistake and the power was the confusion. Now I get 17.66.
That's good,
Thank
ma'am.
you.
Yeah,
Thank you.
fantastic. Okay, so here again the question is more simpler in terms of computing the peak runoff from the catchment, provided the catchment which is going to be taken in this problem, it is said that area of entire catchment is 10 kilometer square. Out of this 10%, 10 kilometer square, 50% of the catchment is having a forest land. Okay, so if I will be like plotting a simple line, so I am just saying that this entire part is of about 50%, and it is having a C value of 0.2. Now remaining from the 50%, it is said that 20% of the catchment is having a grass cover. So I am just taking this as 20%. Okay, so this is a part of grass cover, and what is the C value, percentage, it is given 20%, and what is the C value for this case? 0.45. Then there will be some rest area that is of about 30%, right? So this is a 30% area, and it is said that it is a part of cultivable land, okay, and having a coefficient of 0.3. So if you recall, in the earlier session we have solved this type of problem. Like if we are given that the area percentage, area is given, and then at the same time coefficients is given for individual land use pattern. But if we want the collective averaged value of C, then what we need to do, we need to take a weighted average.
Weighted average.
So weighted average will be taken, and then C value will be computed independently. Now once we get an idea that CW weighted average value we know, then some more information that is similar to the previous question is given. The remotest point, that is L. So here L is again given, that is 2.5 kilometer. You can take it as 2500 kilometers. Now the level is given, that means delta H is given, that is 50 meters. Then C, return period is given as 70.
T.
So here T is 70. Now what we need to find out? We need to find out the peak rate of runoff. How we can do it? It is saying that peak rate of runoff. How we can do this? Any method we can compute this directly, provided the coefficients representing the land property, land use, land pattern.
Q is equal to, I think, C.
Yeah, Q equal to CIA.
CIA, yeah.
So you can use this formula. So for this case, C you can compute it from a weighted average. Then remaining thing is what? I. So I you will be computing from this part. It is given to you. That is intensity, duration, frequency relation. Okay.
Okay.
And then once you got this I value, then what left is that A. So A was how much? It was 100 kilometers square. But still the question is more complex with the computation of this weighted average coefficient. So firstly we need to compute the weighted average coefficient, CWA. So how we will do this? So C1A1 plus C2A2 plus C3A3 divided by A1 plus A2 plus A3. That will be the formula for this case. Then C1, C2, C3 is given to you. Then what left? Area. You need to compute the area. Okay. So here you can, like if you consider this as a 10 kilometers, then 10 kilometer of 50% of the 10 kilometer will be how much? It will be 5 only. So 5 you got it, then 3 you got it, then remaining is 2. So 2 kilometer square area, then 3 kilometer square area, and then 5 kilometer square area. So you can use directly and you can compute the value and tell me what is the CWA value you are getting. Any confusion? We are going with step by step. So here firstly we will compute the coefficient of this rational method first, and then we will compute the I, and then we will use the formula. I hope you got the approach, that what is the main approach you need to follow in this question. Okay. Have you got the value of C? Hello? Hello? Can you hear me?
Yes, we can hear you.
Yes, yes,
Okay.
we can hear you.
So this C will be computed like, or wait a minute, I can. Okay, so if we want to compute C weighted average, so it will be C1 A1. So C1 will be how much? It will be of around 0.2. Then what is its area? It will be area of 5, because I am talking about a forest. This part is of forest. Okay. Then plus it again, if I am taking a grass cover, then it is having a coefficient of 0.45 into 20%. That means it will be 2 kilometers. Okay. So this is a grass cover part, and then what left is that 0.3 multiplied by remaining is how much? It is already a 3 kilometers square. So this part will be a part of cultivable land. Okay. And now you need to add all these areas, so you will be getting a 10 kilometers square. So what will be its value? So 5 to the, that will be somewhat 1, and then it will be coming of around is 0.9, am I right? Or this will again 0.9, am I right? Are you computing? Divided by 10.
Yeah, Balamurugan got C value 0.28.
Yes, I also got 0.28. Yes. So CWA is 0.28. Now we will be computing the I value. So
It's
I,
0.28
yeah,
C.
yes, ma'am, right. So 0.28 is right. So if we try to compute I, so here how I will be computed. So 75 into what is the return period is given, it is given 70, so 70 to the power of 0.125 divided by t plus 10 to the 10 to the whole power 0.5. But now what the question is still a problem is that we don't know the value of t. But yes, if we want to compute, like if we want to apply a rational method, then rational method is applied based on the condition that t, that is a duration, should be greater than or equal to tc. So for this case also we need to compute the tc value. So for that case you can follow this this relation for computing the time of concentration. So I just want to confirm that like I just want you to confirm me that this tc is correct, because in the earlier case sorry
Yeah, it is correct. It is correct. He calculated Balamurugan TC 36
okay,
point.
tc is 36.3, then that's good. Now once we got that value of tc, then using this relation we can have a I value. So I value will be computed like it should be nearly 23.183. Okay.
Balamurugan got I value 18.75.
18.75, yes, definitely there will be a problem. 18.75, let me check it again. I'm also computing.
So I'm also
Okay, just
checking.
for the cross verifying it, because in the earlier problem also there was some mistake in this. So I hope the similar problem is going here also. Wait a minute, let me check first. 0.5.
Yeah, 18.75.
Okay, you are also getting that.
Yes, yes.
So I hope this is correct. So don't confuse with this. So 18.75 will be a right answer. So now we got an idea of I equals 18.75 centimeter per hour, and then C also known to you, that is 0.28. This is a coefficient. Now area you already have, that is 10 kilometers square. Then try to compute the value of QP. QP, how will we calculating? CIA. So for that case what you need to do is that 0.28 into I is how much? That is 18.75, and try to convert these units. Okay, so 17 this 18.75 centimeter per hour multiplied by area will be 10 to the power of 10 to the 6. Okay, it will be coming in meter square, and for this centimeter you can convert it by dividing it by 100, sorry, that is 100. And then
Mm-hmm.
for r you can convert it by multiplying by 60 by 60. Okay,
Mm-hmm. So 18.75.
now tell me the value how much you are getting. I am also computing it parallelly.
So 0.28 into.
Okay, what what is the answer you are getting?
1 Balamugan got 145.81.
Yes, I also got the same answer. So QP will be 145.83, having unit of meter cube per second. So this is correct answer. I also got the same. So there may be some like calculation mistake during like writing this statement. Ma'am, are you also getting the like what is the procedure we are solving it?
I got the procedure. I've not
That's
arrived the value.
yeah, that's good, ma'am. No issue,
My
ma'am.
QP was little different. I made some mistake.
Yeah.
Right. I forgot that 60 divided by 3,600.
Yes.
Yes, I got 145.83.
Yeah. Okay. That's good. Okay. So the next question is related to the culvert, that is an hydraulic structure which is need to be designed for a written period of 8 years. So here we have information of written period, that is 8 years. Then we need to find out the probability that magnitude of flood corresponding to this written period will be exceeded at least once during the next 4 years. So if it is saying that at least once, okay, so whenever you are getting the line mentioned as that the magnitude of flood is going to be exceeded for at least once in entire 4 years, so in that case we need to compute a risk, that is a risk only. Okay, so whatever the probability you are going to compute, that will be a risk, like that will be coming from the risk only. Okay, so here you also have that n value, that is 4. Okay, so if it should be exceeded at least once in a year, then that will cause a risk, and risk is also a part of probability, that is representing a probability. So that how we are representing this risk,
1 minus 1 minus P.
yeah, that is 1 minus p to the whole power n.
And yeah.
Okay, so now using this you can compute here. So for this case what just you need to do is that determine the probability of uh, that is just a part of what is p actually.
Probability.
Yes, probability for what?
Magnitudes
You
of.
can see here, this is the probability for an event having a written period of t corresponding to an exceedance probability, that is representing that it is going to exceed that limit. If it is going to exceed that limit, then in that case p is represented. But if that is not going to exceed, if it is not occurring, then in that case q is there. Okay, so don't confuse with this. P is representing the exceedance part, exceedance probability. So now you can compute it by using the formula. given here. So this probability is nothing but it is part of risk, because the risk is always computed, because once it is going to occur, that means risk is there. If it is occurring at least one time, then risk is there, and that in that case this relation is valid. Okay, Bala Murugan already got the answer, so 0.414 right answer. Good, Bala Murugan, that's good. Then okay, DC. Okay, okay. Ashish, have you got the answer?
Yes,
Yeah, I got it.
1414.
Okay, you already you got it. Then that's brilliant. Then I'm moving ahead now. Okay, so the question here is related to a bridge having an expected life of 80 years. That means n is given 80 years, and the design flood was considered for a return period of 120 years. So design flood,
T.
whatever it is going to be, yeah, it is going to be taken place. So for that case, return period T is given as 120 years. Now the risk associated with the hydrologic design of this bridge is, it is in asking in percentage. So what is the formula for risk? Just in the previous slide you already used that. So it is 1 minus p to the whole power n, and if you extend this, then it will be 1 minus 1 upon p to the power n, and 1 minus, that is a risk. So you can compute it, and whatever the value you are going to get, multiply it with 100, then you will get in percentage. Okay, tell me what is the answer you are getting. I hope this calci and all, it will be allowed during your examination.
No,
No?
Yes, Calci is allowed. Mobile is not allowed.
Ah, yes.
no. There is a. They have the in calculator in the system. You can use that calculator. That.
Oh, right, right. They'll ask
Okay.
us to use in the system,
So
right?
it will be just like a computer based examination.
Yes.
Yeah, yes, proctored
Okay.
online
Got it.
system.
Got it. Got it. Yes. Good.
Last assignment also two answers were wrong. Last two.
48.8% is the answer.
48 point. Ma'am,
Balamurugan also got same answer.
what are the questions?
I, I was talking about previous assignment.
Yeah.
We worked the problem on Muskingum method, no? River
Yes.
reach.
Right.
So that and the peak time delay. They are related questions, 12 and 13
Ah,
of
yes.
previous assignment.
Yes.
Both the questions were wrong for us, what we worked. We lost 6 marks. I don't
Okay.
know why.
Okay.
I thought if I had your mail ID, I would have communicated the answer what
Okay.
we
Okay.
worked. We did it properly, but I don't know why it's wrong.
Okay, I'm just writing my email ID also.
Okay, please.
I can write it in chat box. That will be good. So you can like I can give you some like explanation to those questions also. This is my email ID, institute email ID. Okay, you can send me your queries with that screenshot of those questions directly. I can solve those questions again and revert you back. Okay, and if I am getting like a problem where answer is still not matching, then in that case I will be raising those questions with NPTEL team. Okay.
Okay, thank you. Because we had the same thing the previous one also, no?
Yeah.
So, but you're busy. You're going to go for the conference.
Yes, yeah, but I can manage, not an issue.
Okay, okay,
Okay,
thank you.
yeah, sure. So Ashish, how much percentage you are getting? 48 point something?
48.8%.
48.8%. Okay, let's check. What is the answer? Yes, your answer is right. 48.8%. You are right.
Balamurugan also got same answer.
Ah, that's good. Brilliant. Brilliant. Good work. Okay, now moving to the next part. Again, the question is related to the, it is saying that evaluate the return period. We need to compute the return period this time, considering that hydraulic structure construction in a river with an assurance of 92.5%. So if you recall the previous question, there was also one word called assurance. So assurance is mean that reliability. Okay, it is saying that reliability, that is opposite of 1 minus risk. Okay, reliability, that represents it is a safer side, because we are considering that we want the structure to be 90% safe. Okay, with only 10% risk involved. So 10% is the risk and remaining reliability is 90%. So reliability is given to us, and then number of years, for how much years this structure should function. So n is given, n is 35 years. Now what we need to compute, we need to compute the t value. Then if you see that reliability, if I am saying that 1 minus risk, then 1 minus risk is how much? 1 minus p to the power of n, right? If you open this, then you will be like cancelling out 1 1. Then what left? It will directly come up with 1 minus p to the power of n. That will be the relation. Now you need to use this and try to get the value of t from here. So for that case there will be a power. So power will be like it could be only solved if you are taking a log of that, because reliability is given to you. Reliability will be how much? It will be 0.925, and it will be equivalent to 1 minus p. P I am taking it as 1 upon t. Okay, and to the power of n. N is how much? It is 35. Now take a log of that. Otherwise this power will be causing a problem.
0.925 is equal to 1 minus 1 upon t. 55.
See, this t should
So we
become,
have to take log both sides, no?
yes, 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 you can take a log on both sides.
Log
ln
0.1925.
0.925 equals
So 35
35
log
ln
1
of
minus
1
1
minus p,
minus t.
yes. So now you can compute this value. So ln 0.25 is 0.925. It is coming of about minus 0.07796, and if I am dividing it by 35, then I will be getting a value of equivalent ln 1 minus p. So I am dividing it by 35, so I am getting a value of about minus 2.2274, or I can take it as 5, a round figure, 10 to the power minus 5. Now there is a ln. Okay, so ln 1 minus p. How I can get the value of 1 minus p? You need to take exponent, because you have to transfer this function. So if you're transferring this function, it will
Can
be
you
coming.
explain again?
What?
Can you explain again the step how to take exponential? I forgot this one.
Okay, so basically, whenever you are having a function like if you are having a value and
Mhm.
ln of x, you can say, okay, whenever you are having this kind of function, so if you want, like, there is a ln is always expressed as ln to the power of base e. Okay,
Mhm.
whenever we are taking a log, then log is always expressed in the power of base power of 10.
Mhm.
So if you are about to transfer this function, so what happens, this entire e is basically transferred. That is why e is basically coming. Otherwise, if you take a log of 10 to the power, like if there is a function called a equals log of 10 x, So if you want to take out x, then what will be transferring? This 10 will be transferring now. So what you will be getting? 10 to the power a equal to x. Okay,
Hmm.
this is the concept. So how this e is coming? Just because ln is always having a base of e. So now if you want x to be out from ln, what happens is that e should be transferred to the other side. So if e is transferring, then it will become e to the power a, and in the other side x will be left. Because this e is transferring, that means ln is entirely transferred to the other part.
So I got log of 0.925. Just you can I'll calculate. Like
Yes, log of, right?
925, 0.925.
Then you will be getting this much of value, minus 0.07796.
Log of 0.925. No, I'm not getting it.
How much you are saying? Log or ln? Don't take log now, take ln.
ln of 0.925.
Yes,
So it is 0.077.
minus
Yes,
0.077.
yes, yes, yes.
Yes, so you got the value
Minus 0.077.
0.077.
ln of 0.925.
Yes, 0.077.
Yes. Then on the next side,
Now
35
now
log
what you
1.
need to do is that there is a this coefficient is there, 35. This is a constant value, because
Yeah.
this ln couldn't be transferred till
Hmm.
you remove this part. So 35 is basically, it will get divided. Now this
Okay.
remaining whatever the divisible part you are getting, this is this much value, minus 2.2275 into 10 to the power minus 3, and
So
it
I
will be
got 2.2275
how much?
into 10 to the power minus 3.
Yes, yes, yes. Minus,
So
don't forget the minus. Minus is also
2.22,
there.
yeah, minus sign. 2.227
7.5 into 10 to the power minus 3. Right. You are right.
minus 3. And other side I got log
ln
1
ln 1 minus p.
ln 1 minus 1 upon t.
Yeah, yeah, yeah. Oh, don't. Yeah, if you want to open p, that is good. Not a problem. Now again, Ashish, whatever the concept just you seen in that case, now transfer this ln again. Now you need to transfer this, otherwise this 1 minus p won't get open.
So, okay,
So there
let's.
is a base E, ln having a base E. This E will
Hmm.
be transferred to the other part.
So, okay, that e is become e to the power minus
Yes,
2.2275
good,
10
right.
to the power minus 3, and
This will be equivalent to 1 minus P.
oh, this remain the same 1 minus 3.
Yes, yes,
Okay,
yes,
now I
yes. 1
got it.
minus P will be here only, because it is a just a your function. It is a your
Uh,
function.
Now I got it. I remember now.
Okay, okay. Now get the value of E from here.
Yeah. Oh.
Don't if you are taking a log, then don't forget to take a 10, because in that case e is not going to come. If you have taken a log, then through cal c you will be getting a log kind of value, and if you take anti-log of that, so for that anti-log you need to keep the 10 instead of e, because e will only work in case of ln.
Hmm.
Hmm.
Minus 2.2275.
So how much you are getting? E to the power minus 2.2275 to the power minus 3. Okay, I'm getting somewhat around 0.99.
99.
Yes, and now subtract it by
Triple
1.
seven.
Yes, yes. So if you subtract it by 7, then you will be getting 2.225 into 10 to the power minus 3. It is equivalent to 1 upon t. Now if I want to t, then I need to take a reciprocal of that.
I got value of this 0.99. Now I have to calculate t value.
Yes, so take subtract with 1 now first.
Yes, yes, yes.
Subtract it with 1.
Yeah. So 1 minus point, I'm sorry, 2.22.
That's good. I just wrote here. 2.225 into 10 to the power minus 3. Now it will be equivalent to P or 1 upon T, because that both are similar.
So I got 2.2250, 10 to the power, P value is equal to
Yes, good, good.
2.225.
Now you know that P is what? That is
1
equivalent
upon
to 1
T.
upon T. Yeah. So if you
Yeah,
want to take out, if you want to compute T, then you have to take a reciprocal of that.
yeah, 450.
Somewhat 450. Here you are getting that. Yes,
449.43.
yes, yes. This is the answer. You got it.
Score 49.44.
Okay, ma'am. You also got that. Brilliant. Good. Ashish, you can also tell me the answer from Bala Morgan side.
Yeah, you already got the answer.
Okay, okay, okay. Then that's good. Okay, now moving to the next question. So here, question is now having some exposure to the next topic. Like whatever the values we are solving right now, we will be adding the Gumbel's method now to that same to the earlier problems. So here see that there is a hydraulic structure which need to be constructed in a river with assurance of 90%. That means what is the assurance? What is the assurance? How we are representing it?
Well, minus
Reliability.
It is a
reliability.
reliability. Yes, it is a reliability. Reliability that is equivalent to 1 minus risk. So we have an idea that it is 90%. That means it is 0.9. But it now it is saying that this construction should last for next like this structure should be safe for next 45 years. That means n is given number of years. It is given that 45 years. Now what left is that we need to evaluate the value of Gumbel's reduced variate. So this if it is asking that Gumbel's reduced variate, that means it is saying about YT. It is asking about the YT, because if you remember that in case of Gumbel's distribution there was expression like xt equals x bar plus k into sigma. Then there is a x bar and there is a sigma. You already know that sigma is a standard deviation, x bar is a mean. Then what left is that k is a frequency factor. Don't confuse with this. This is a frequency factor. Now if you open this frequency factor, so you are getting yt minus yn bar upon sn. Okay. Now this yt is called as a reduced variate. Reduced variate. Also, if you say that this Sn, so Sn is basically a reduced variate for standard deviation function. And this Yn is for what? This is a reduced variate for mean. That is average value. This is a reduced variate. So all the parameters are basically a reduced variate only. But this, if we are talking about Yt, then this is a reduced variate for the return period. That is time t. Oh, sorry, return period t. And how you are going to get the yt? Tell me the formula. We have solved multiple questions. So tell me the yt value. How we are computing this?
YT, Y bar, 1 minute.
Yt will be expressed in form of return period. That will be t. So what is the relation for that? Somewhat in terms of ln.
Minus ln of.
Yes, yes, that is the expression. Yes. So minus ln of ln what? T upon t minus 1.
T
Am I
upon
right?
T minus 1. Yes.
So here you need to compute this. This is the question it is asking. So here we have reliability, we have number of years, and we want to compute yt. Now anyone tell me that how we are going to proceed, because we have solved multiple questions on Gumbel's. Now if we want to compute yt, what is the parameter do we need and how we can approach?
Yeah.
So looking at this relation directly here, what do you think, which parameter we need to compute first so that we can have the direct output of this? So that parameter is return period T.
It's given as 45 years.
What, ma'am?
It's given as 45 years.
No, no.
Return
It
period.
is it is a for the construction period, that how much for how much life it should have the like a safety. Okay, for
Okay.
that case
Okay.
it is given. But if we are talking about a return period, then that return period will be associated with the past record of data, past record of
Okay.
flood data.
Ah,
From
yeah,
that
yeah.
you are getting the T value.
Okay.
So yt, for that we need to compute a t first. And how we can achieve the t value? This could be achieved by using the reliability that is given to us. So reliability, we know that it is 0.9 it is given, and then there is a relation 1 minus 1 upon t to the whole power n. Now solving this directly, you can get a value of t. And if you get a value of t, you can directly substitute here and you can get the answer of yt. Ashish, any confusion so far? Do you think it is easy?
Yeah, it's easy, no issue. I have
Yes.
to confuse.
Just you need to keep all the formulas running in your mind. So in the earlier problem, what was the reliability? It was nearly 92.5%. Okay, and in this case it is given 90%. But at the same time, n is also changing. N here is 45. So you need to compute it again. You need to take ln and then again you need to compute this value. Do I need to compute it parallelly, or
Just
you
I want
or
to
you are
put
computing? Okay, take your time.
0.91 minus 1 upon t to the power n. Okay, let me just put.
Yes, 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 it is right. Then take a
Mm,
log of this again. So ln of 0.9 equivalent to n, that means 45. Ln of 1 minus 1 upon t.
and
Now compute the value of ln. So
n
ln
is
of,
45. N is 45.
yes, ln
Log.
of my 0.9, it is coming of
We
around
say as of now
minus
when
0.10536, and this will be equivalent to 45 ln of 1 minus 1 upon t. Now transfer this 45 here.
yeah, 1 minute. Log 0.9 divided by 45. So minus 2.341.
Yes, it was around minus 0.105 something, it is coming ln if you are taking ln.
Point nine log. No, I am dividing it for by 45
Ha
also.
ha
So
ha, that's good. Yeah, that could come. Yes, tell me the value.
2.341 into 10 to the power minus 3. It's minus. Its value is in minus.
Minus, okay, got it. Then there is a
Now
ln
we have
of
to
1
take
minus.
exponential of this. No?
Yes, you need to take exponential of it again. So e
So
to the power minus 2.34 into 10 to the power of
1
minus
minus
3,
1 upon
and
t
that will be equivalent to 1 minus 1 upon t.
exponential. The exponential value is 0.997. 1 minus 1 upon t. So 1 upon t.
0.9977.
Yes, okay, good. So you are getting 0.9977. This is the value, and then you need
But
to
I'm getting 0.333 T,
T. How much you are getting?
333.
333. Okay. Yes. Let me compute it. Okay. We got. Are you getting this value?
Yeah, 0.9997. I got it.
99766. It should be like this.
Yeah, 0.9976. Yeah, I got it.
Yes. Then 1 minus, if we are subtracting,
So 1
0.966.
minus 0.9997.
No, I am getting 427.
Okay,
I am getting.
it's 2.4. Okay, 2.4 into 25 minus 3. Then there's the answer. Yeah, somewhat 41642 I'm getting.
427.
427.
427.
427.4.
Yes, yes, yes. It
I
should
did
come
some.
427. It is right.
Actually, we need to calculate 0.997661 minus 0.99766. No, 1
If
divided
you
by.
will be subtracting now, you will be getting
Yeah,
the.
yeah, it's okay. We need to take values up to 5 digits so that we get 427. If I take value up to two
Yes.
digits, I get some lesser years.
Yes, yes, yes.
Slight difference in decimals making large difference in the t
But
values.
you can't like looking at the values, you can't take 0.99 now, because that doesn't make sense, because if you
Yeah.
are taking a 99, then it is just going to be 1.0
Okay. Okay.
in that
Okay.
case.
I
So
got it.
you need
Got
to take a round figure in last maybe
five
five,
digits.
yes, 4 or 5 digits. In that case it will make sense. Okay, now come to the Gumbel's reduced variate. We need to compute this. So how we are going to do this? This is the formula we need to compute. So put the values and see whether you are getting this YT.
Okay. By t is okay. Log of.
Okay. Okay, YT is 6.06. Yes, yes, yes. Right. Okay, so you got it. Okay, that's brilliant. Good, Balamurugan. Have you got the answer?
1 minute. 4, 2, 7.
6.0533.
Yes, right, ma'am. Right.
But if we take log at once, we get the value 4.056. But if we take twice log, the value is different.
How we are taking a log? Let me check. If I am taking ln, then there should be 427 and divided by 427.4. Okay, then I am subtracting it by 1. So for this first log, I am getting in the power of 10 to the power minus 3. If you are solving the inner part of ln, this ln, firstly you have to solve this.
Yeah.
So if you
First,
solve this value, you are getting a value of around 2.3424
1 minute,
into 10 to the power
47.4
of minus 3. Now again
divided.
you need to take a log of this,
1 minute.
because there is one log other side.
I get
1.0.
6.056.
What, ma'am?
I get 6.055. Okay.
Okay, yes, ma'am, right, it's correct. Getting the answer?
Okay, I got it.
Okay, so you got this 6.056.
0.056. Yeah, I got
Yeah,
it.
that's brilliant. Okay, now the last question here of this session is, a flood series data yielded a mean of 2300. That means from the entire flood series data, it was fitted using Gumbel's probability distribution, and in that case it is found that mean of the entire flood series data, that is x bar, is going to be 2300 meter cube per second. Now what next is that standard deviation. So sigma is also given 470 meter cube per second. Now the design discharge to be considered for a weir to be constructed in the river with an assurance of 90% that it would be a function for a last 50 years. Okay, so n is given, that is 50 years, because it is needed that this entire construction should be in the safer side for nearly 50 years. And then assurance is also there, that means reliability. So reliability is given, that is 90%, that means 0.9. Now the question is asking that we need to compute the design discharge. Design discharge means,
Q.
yes, but if it is saying that we need to use a Gumbel's method, then tell me which parameter is going to be calculated now. If we are saying that design discharge, you know the relation, Gumbel's method, right? So what is the parameter we are looking for in this question? Design discharge, right? So it will be xt.
XT,
Don't
okay.
confuse.
Okay.
Yes, it is xt. That is the design discharge. This is representing a design discharge value. If you are using a Gumbel's method, then xt will representing a design discharge value, that is a target value. Okay, so now you need to go for xt, and how you can achieve this? Say xt, for xt getting this,
XT is equal to X bar plus sigma
k
K.
into sigma. Yes, brilliant. Now we have the data for x bar and sigma, but we don't have idea for k. Now how we'll achieve this? If we don't have an idea for k, then how will I approach this?
So
And tell
Vk
me,
is equal to Yt minus Y bar n upon Sn.
okay, so K, you are saying that Yt minus Yn bar upon Sn. We need to use this, okay? And see, there is a condition that assume that entire flood series data as an infinite in sample size. So that means Sn and Yn will be taken as constant coefficients.
Constant coefficient.
Okay, so this is given to you, but still in order to get the K value, you got the Yn and Sn, but still there is one missing parameter, that is Yt. So Yt is not known to you. Then
Then
how you can proceed? How
yeah,
you
we can calculate by taking log of t upon t
Yes,
minus
so
1.
minus ln of ln t upon t minus 1, that will be there, but still again there is a problem. We don't have the value of t again. Then what next? क्या करोगे? What we will do? We don't have the t value na in this question. We don't have the t value,
Mm-hmm.
but there is some additional information still in order to compute the t. That is that information is assurance.
Okay, yeah, fine.
So assurance is there. So that means reliability is given to you.
Reliability is easy to use.
Reliability is given. That means it will be expressed as 1 minus 1 upon t to the whole power of n.
Hmm.
Reliability is with you, that is 0.9, and also it is 1 minus 1 upon t to the whole power of 50 years. Now once you get the t value, you have a step to proceed.
Hmm.
Got it?
Yes, yes, yes.
So this is the way you need to approach the problem. That firstly try to see that what is the from the Courser resolution, from your Courser resolution of your thinking. Firstly see that what are the raw material that is being given. Then you come up that this is a Gumbel's method. So quickly you should have an idea that what is the relation representing the Gumbel's method. So you got that xt is equivalent to x bar plus k into sigma, but still now you are searching for what are the data we have. So you got that x bar is given and sigma is given, but still k is missing. Now you are now again searching for how I can get the value of k. So for that case you have reached the k relation, that is yt, and then for that case yt was still missing. Then you come up with this relation, that is minus ln t upon t minus 1, but still t is missing. For that case reliability is there. So see that there is a lot of depth you have to go in this question, and then you are getting the entire result. So here, just for your easy understanding, I am just saying that this reliability, based on the reliability, this return period will be around 475 years. So taking this 475 years, now tell me the value of yt. That will be minus ln of t upon t minus 1. Tell me the value. See, here again it is mentioned that what are the coefficient do we need to take for yn and sn. It is mentioned here. If we are having an infinite number of sample size for flood discharge or any kind of hydrologic data, then we need to take a constant value, that is 0.577 for yn bar, and then for sn that is 1.2.
6.164 I am getting.
How much?
6.164.
Yes, it is right. Yes, yt is there. You are correct. So yt you got. Now what is your next step is that k. Now you need to compute a k, and for that you can use this formula that is given. This formula you can use directly. If someone is asking that what is meant by yn and what is meant by sn, then don't confuse. Okay, because this is the reduced variate for mean. Yn bar is representing a mean part, and then what is sn? Sn is a reduced variate for standard deviation. Okay, so don't confuse, because sn is part of standard deviation, yn is part of mean. Now tell me the value of k.
Just a minute.
Ma'am, have you also got the value of yt equals
Yeah, yeah, yeah.
6.16?
I got 6.1622.
That's brilliant.
4.356.
Yes, k is here. 4.3566. That good. Now you just only need to put all the information in this equation. That is xt equals x bar plus k into sigma n minus 1.
Mhm.
And see whether you are getting this xt value. Somewhat 4300 cubic.
Yeah, I got 4347.612.
Ah, good. That's good. So this is the way you need to approach this question. Okay. So this question is very good. Like from my observation, it is taking your thinking to a more deeper and deeper level. You are adding all the concepts you have learned so far in statistical hydrology. You are compiling everything, because in most of the cases you will be solving the problem related to Gambas method. That is more common in case of these extreme events, because flood is kind of like we are making a prediction. Okay, so in that case we need finer, like accurate information related the flood. Okay, so in that case the Gumbel's method makes more sense. Ma'am, have you also got the answer for this?
I didn't come to that level. I'm just working. I'll
Ha
get
ha,
it soon.
yes you can, ma'am. I'm waiting. Yeah, okay. Okay, I guess Balamurugan already left. No issue.
Yes, sir. I got four three four
Okay,
seven point six
how much you got, ma'am? Okay,
4,347.60. The same value.
brilliant, brilliant. Okay, so this is the right answer. So this way you have to approach this problem. Okay, so thank you for keeping patience for this wonderful uh, assignment session. So ma'am, you can send me those problems via mail. I will be able to solve, like I will solve those problems and send you in form of PPT only. Okay, I will send you.
Oh, okay, okay, sure.
Yeah,
I think last week we mentioned orally. I'll put that also in the mail and send.
yeah,
And the previous one, last two problems.
yes, sure, sure, ma'am. Yeah, that will be
So
good.
should I type what we work plus what they have given, both, right?
Ha, yes, ma'am. That will be good. Yes, in that case, I will be understanding in more way.
Uh, it feels bad after understanding, working, getting it wrong.
Yes.
Feels bit.
Okay, ma'am.
Thank you very much.
Okay, Ashish. So now I'm about to stop this presentation. Okay.
Yeah, yeah. Thank you for your teaching and making us understand the lecture.
Valuable inputs.
Yes, yes. Thank you so much. Thank you so
If we
much.
have any doubt, we will just drop a email to you.
Yeah, sure. That will be good. I will be more happy to answer those questions. Okay.
Hmm.
Okay then. So I'm
All
stopping
the
now.
best for your conference.
Thank you so much, ma'am. Thank you so much.
Enjoy your trip also.
Yeah.
Thank
Thank you.
you.
Okay. Thank you, Ashish.
Okay, bye. Take care.
Yeah. Bye.
Bye. Thank you very much.
Yeah.